Am I audible to all of you? All right. Good morning, everyone. So, today is our third lecture on science and technology. Please allow me to, yeah, the recording is on. All right. So, students, anything to ask? Anything to ask from the last class, from the previous class? What was our last topic of discussion, guys? What did we discuss last? Good morning, all of you. What did we discuss last? Tell me, guys, please. I'm sorry, Vani, I was not able to hear you. There was some audio issue. Radioactive elements in nature. All right. So, general science part we have completed. General science part of nuclear energy we have completed. That is radioactive elements in nature. This part is over. Okay. Any questions you guys have from the previous class? Any questions you have? Okay. So, students, as you know that the subject of science is heavily, current affairs loaded. It has a lot of reference or relevance of current affairs. So, Magnum book of PMF has already been shared with you. You can start reading the Magnum, but actually in last 1.5 year, they have not been much development in nuclear technology. So there is something called BSR Bharat small reactor that we will talk about shortly in couple of lectures. So that particular part you can get all that help from Magnum. But when it comes to nuclear energy, you have to rely on the class notes more, because I have covered nuclear energy in more depth in the class. But when it comes to space technology, there are a lot of facts for which you can refer to the Magnum. Okay, so in that way we will interplay. So I will keep telling you when to start reading the Magnum, when to concentrate on the class notes, all these things. Okay, so don't be under this impression that that you only have to read this or no book is required. The book will be required, but for some areas. I will tell you which areas. Okay, so as and when the time will come, I will be informing all of you. So guys, let us start. So we have completed up till this part. If I just give you a quick recap, I have told you that what is an isotope? Isotopes are those elements which are having same number of protons and different number of neutrons, right? Same mass, same atomic number, different mass number. We took example of protium, deuterium, tritium, and then later on we also saw isotopes of carbon, C12, C13, C14. Then we discussed what is the meaning of radioactivity. I told you radioactivity is a phenomena which is characterized with instability of a nucleus, and that happens because of the imbalances of charges within the nucleus. And then I told you the radioactivity is always a temporary phenomena. Once an element is radioactive, if it loses all the instability out, it will become a stable substance, right? We have discussed up till there. Then I told you that in nature, all the elements which have atomic number more than 82, they are naturally radioactive. And all elements which have less than atomic number 81, less than atomic number 82, they are radioactive, but only few isotopes. Not all elements are radioactive. By the way, 82 is of this lead. Then we also discussed the radioactive radiations of alpha, beta, gamma. What is the risk that alpha rays carries? How far they can penetrate? What is the risk that beta rays carries? How far beta rays can penetrate? And what is the risk that gamma rays carries? We have discussed all these things. I also told you that it is the newly born children and elderlies who are at a bigger risk, right? I hope all of you guys are able to understand, who are at a bigger risk of mutations. I hope all of you remember. Now guys, we were discussing weak nuclear force. I did not tell you anything about weak nuclear force, right? So we have discussed strong nuclear force, we have discussed electromagnetic force, we have discussed gravitational force, but we did not write anything about weak nuclear force. So what is weak nuclear force, guys? This is what we are supposed to write down. So please write down weak nuclear force. And you know what, guys? This release of radioactive radiation, the release of radioactive radiation, right? The release of radioactive radiation from an unstable nucleus in order to attain stability, this is basically caused due to weak nuclear forces. I want you guys to please write down. Please write down, guys. Weak nuclear forces. Point number one. Acha, tell me, guys. First, you have to answer. So, this is the force that is pushing the instability out. Mind my words. This is a force that is pushing the instability out of the nucleus. It is trying to push the instability out of the nucleus. So tell me, guys, think about it. What kind of nature this force will have? Will it be attractive or repulsive? Remember, it is pushing the instability out of the nucleus. So should it be attractive or repulsive in nature? Tell me, guys, quickly. What type of force? Of course, it has to be repulsive in nature. Very good, very good. So please add on point number one. It is a repulsive force. You can write in the bracket, it pushes the instability out of the nucleus. Weak nuclear force, it is a repulsive force. It pushes the instability out of the nucleus. Right? It pushes the instability out of the nucleus. It's a repulsive force. Point number one. Second point, please write down. It's a repulsive force, pushes the instability out of the nucleus. Second point. It is a force responsible for the release of radioactive radiations. It is a force responsible for the release of radioactive radiations. It is a force responsible for the release of radioactive radiations in an unstable nucleus. Radioactive radiations in an unstable nucleus in order to attain stability. In an unstable nucleus in order to attain stability. So it is a force responsible for in an unstable nucleus in order to attain stability, right? I hope all of you understand. In order to attain stability by the release of radioactive radiations, ऐसे लिख लो. By the release of alpha, beta, gamma and heat, as you can write down like that. By the release of radioactive radiations in bracket alpha, beta, gamma plus heat. Okay. So by the release of alpha, beta, gamma plus heat. Acha, I didn't tell you about X-rays. Guys, alpha, beta, gamma are three types of radioactive radiations. Right? Got it? But what about X-rays, guys? You have heard of X-rays? Whenever, accidentally if our bones gets cracked or if we develop any kind of fracture, we have to get the X-ray scan done. Then only the doctor knows how many fractures are there, what is the intensity of the fracture, and what is the right treatment. Whether you need to, implant a rod to hold the bones together, or without a rod it can be done. All of you must have seen that, right? So it is something which is called fracturing. So what kind of radiation is X-rays? Is it a radioactive radiation or a non-radioactive radiation? Tell me, guys. X-ray, what do you guys think? Radioactive or non-radioactive? Radioactive or non-radioactive? What do you guys think? Yes, X-ray is also a radioactive radiation. Actually, then why didn't we write X-ray? We only write alpha, beta, gamma rays. Why didn't we write X-rays? Actually, guys, X-rays are nothing but low energy gamma rays only. X-rays are nothing but lower energy gamma rays. They are no different than gamma rays. They work exactly like gamma rays, but they are of comparatively lower energy than normal gamma rays. So you can please write down, X-rays are also emitted from radioactive substances. They are low energy gamma rays. So they are also emitted, guys. Okay. So remember, guys, X-ray is also a radioactive radiation and it is emitted, and they are nothing but low energy gamma radiation. Are you guys able to get it? Low energy gamma radiation, X-rays. I believe all of you guys have been able to understand this part, right? So this is what we have under the second point of weak nuclear forces. Now, guys, tell me, where are these forces going to be found? Is it a short range or a long range force? Mind my words, these radiations, alpha, beta, gamma, these radiations can travel to a long distance. Of course, alpha radiation do not have a power to penetrate. So alpha radiations can be stopped very easily. Beta radiation can also be stopped easily because they can penetrate only to some extent. And gamma rays can pass through thin walls, it can pass through a lot of objects and can easily travel up to hundreds of kilometers. You can see gamma rays traveling. But what kind of force is it? So alpha, beta, gamma rays may be able to travel, but the force is only within the nucleus again, right? Just like strong nuclear force, the force is found within the nucleus to maintain the integrity of the nucleus. Weak nuclear force is also found within the nucleus that enables the release of instability out of the nucleus, right? So this is what we have under alpha, beta, gamma. So please write down, it is a short range force. It is a short range force. You can again write down in the bracket, it is limited only within the nucleus. Short range force limited only within the nucleus. Okay, it is also a short range force and it is found only within the nucleus. Short range force. I hope all of you guys are able to get it. Short range found only within the nucleus. Again, short range. Perfect. And last point, write down. You guys tell me the last point. We have already written that strong nuclear force is the strongest force in nature. Gravitational force is the weakest force in nature. Second strongest force is electromagnetic force. So where will the weak nuclear force come? It will be the third strongest force, right? Or you can say second weakest force. So please write down, it is the third strongest force in nature. Write down, it is the third strongest force in nature. So guys, we have 4 forces and now we have completed all the 4 forces. This completes our discussion on general science part of nuclear energy. But guys, it does not mean that we will not be needing any more general science. We will require them, but we will see it only from the context of applications of nuclear energy. Okay. So now I hope all of you guys have been able to understand. Please write down yes in the chat one time so that I have a guarantee that all of you have understood. Right? Sagar, you have understood. Very good. What about Bharat? Shafiq, very good. Vani, you have also understood. And all right. So Bharat, did you understand? All right, very good. So this basically means that all of you have understood up till here. Shritama is not there today. So guys, let's see if you can answer this question quickly. See if you can answer this question. Jaldi batao. Quickly, guys. Come on, guys. Very simple question. The known forces of nature can be divided into 4 classes, that is gravity, electromagnetism, weak nuclear and strong nuclear force. With reference to them, which one of the following statement is not correct? It is asking not correct, guys. Of course, gravity is the strongest. No, it is the weakest. Gravity is the weakest force. Simple question, right? It is a previous year question only, 2013. It is the weakest force. I hope all of you get it, right? Now, guys, next point. There are some more questions that will come up. Now guys, this is where we are starting the topic of nuclear technology. And I want you guys to please write down. This is now guys, when UPSC asks questions, there is a higher chance that you can be asked questions from here. Whatever we discussed in the previous 2 classes, there is also a possibility that UPSC may ask questions from there, but there is a bigger chance, there is a greater chance that if they would want to ask a question, they may ask from here. Okay. So please write down 3 stages of India's nuclear energy development program. 3 stages of India's nuclear energy development program. Okay. And I want you guys to write down this, whatever is given here, I want you guys to write it down quickly. I'll obviously write the full forms. PHWR means pressurized heavy water. You guys know what is heavy water now? Pressurized heavy water reactor. D2O stands for heavy water. Heavy water. FBR means, don't worry about it guys, all the things you will be able to understand. Fast breeder reactor. Then here in the 3rd stage, AHWR means advanced heavy water reactor. and TBR means thermal breeder reactor. Right? These are the three stages. These are the three stages of India's nuclear energy development program. Quickly write down. The moment you finish, you please write down done in the chat or why in the chat. Yes. Quickly, guys. Write it down. Come on, guys. You have to be very quick. All right. Very good, Vani. So, this is what is known as the three-stage reactor. And when you look at this three-stage reactor, you can see that India's nuclear energy development program, the stage 1 fuel, it says natural uranium. Only one student has been able to write. Come on. Everybody else. See, with a very slow handwriting, that is also something which will not help you in the exam. All right, Bharat, very good. Quickly, guys. Shafiq, very good. All right. So let me start now. So, guys, what you see here are the three stages of India's nuclear energy program. But before I talk about the three stages, let me quickly talk about a short history. Yes, Hariom, please.
I think coolant should be, sir, barium and krypton rods, right?
No, barium and krypton.
Yeah. Cadmium rods, sir. Rods, it can absorb neutrons. That's what.
So that would be control rods. Control rods are not mentioned here. I have only mentioned what is the name of the reactor, moderator and coolant. Control rods I have not mentioned. Control rods are mostly boron and cadmium or molybdenum. Boron, cadmium, molybdenum.
Yes.
Right? So those are control rods. Control rods are meant for controlling the energy of the reactor. Right now I've just given what is the reactor. Control rods, I'll talk about it later when we actually discuss controlled and uncontrolled nuclear reactor, right? But I would need your contribution there, Hariom. You can obviously add some value there also. Okay. So I hope all of you guys have been able to understand. So these are the three nuclear reactors. Now, guys, please pay 100% attention here. So, guys, these are the three nuclear reactors that we have. And when you talk about the three nuclear reactors, before I talk about the reactors, let me quickly give you a short history of nuclear energy. Guys, when it comes to the energy of the nucleus, today we know that the nucleus holds the strongest force inside it. We know this. But guys, you'll be surprised to know that the discovery of nucleus itself is not very old. Nucleus as an entity, it was just discovered in 1911. In 1911, there was a British physicist. His name was Wilhelm Ernest Rutherford. Wilhelm Ernest Rutherford, or famously called the Rutherford gold leaf experiment. And Rutherford in 1911 discovered the nucleus. So guys, discovery of nucleus is not very old, right? Hardly 115 years old, right? 114 years. Got it? that was the time when nucleus was discovered. And guys, inside the nucleus, protons, neutrons, they were still not known to us, but we knew that nucleus have got a positive charge because protons are there inside the nucleus and neutrons are neutral. Then guys, what happened? So we all realized that nucleus was discovered in 1911. Although guys, theoretically, the scientists knew that the nucleus may be holding a lot of energy. A lot of energy may be there inside the nucleus because it is holding so many number of protons. It must be having a strong force to hold itself together. So theoretically, we knew that nucleus may be a reserve of a massive amount of energy. But in 1911 only we discovered where the nucleus is. Where exactly the nucleus lies in the atom, it was only discovered in 1911. Then guys, in 1913, from the nucleus, there was a student of Rutherford. The student of Rutherford himself, his name was Niels Bohr. Niels Bohr, he was a Danish. Now Rutherford was British, Niels Bohr was from Denmark. And Niels Bohr discovered the 3-particle model, or he created his own model of an atom, where he actually located nucleus at the center and he located electrons in various orbits around the nucleus, right? And he basically talked about energy levels of the electrons and all those things, right? We don't have to get there. UPSC will not ask that, deep science. But what you should know is that the discovery of nucleus happened in 1911, and just after 2 years, we got the entire atomic model known as the Bohr's model. Got it? Now what guys, in 1911, we discovered the location where the greatest energy or the greatest force of the universe lies. 2 years after that, we also discovered how the entire atom looks like. But guys, after having this major discovery that atom is going to be shaped like this, nucleus is going to be at the center, we did not see any major development for nearly 30 years. For nearly 30 years, people did not see any major development coming from nuclear energy. It's not like nuclear research was not going on. It was going on in Europe and maybe in America, but we did not see any major revelation after this Niels Bohr experiment, right? Or Bohr's model. Many people say that the reason could be because nuclear energy, it is a highly capital intensive technology. You have to put a lot of investment to study nucleus because it is so small that it cannot be observed that easily. And you know that in 1914, First World War started. So Europe this itself did not have money to put for nuclear research. And when in 1918 the First World War ended, lot of European countries were destroyed. So a lot of money was required to rebuild the lost infrastructure, to rebuild all those lost connections, buildings and all those things. So a lot of money was needed. And then in 1929, Great Depression of America happened, which led to recession, right? Both in Europe and America, right? And then when both the things got normalized, when things started improving, finally rise of Hitler started happening. And Hitler is heavily invested in militarization of Germany, and that's again all the other countries also started doing. They started militarization of their own country as well. So it is said that from 1914 onwards, Europe was somewhat in a highly agitated state. It was nearly at the stage of war from 1914 to 1945, right? So the stage of war did not stop at all. But guys, something very dramatic happened. And it happened in 1941. Many of you might have heard of the Pearl Harbor attack. The attack of the Japanese on Pearl Harbor of America in Hawaii. You know what guys, this is something interesting part of history as well. Americans used to think before the Pearl Harbor strike that no country can attack them. Because we all know America from both sides is completely protected from large oceans. One side it is Pacific Ocean, on the other side is Atlantic Ocean. Completely protected. The only place from where they can come is from either North Canada or South Mexico. So America needed to simply have a strong, border protection or strong border management with their neighboring country, and that's how America is completely safe. So Americans always thought that to attack Americans, it will be a difficult bet for any country. So they always had this impression that they are naturally in a position which is well protected. But guys, Japanese proved their perception incorrect. Japanese were the first people who took more than 50 bomber aircrafts and traveled all across the entire Pacific Ocean, reached uh, Hawaii, and did large scale bombardment, and then went back. Now, when this happened, guys, the reason for Japanese was not to provoke Americans, but it was basically to destroy the warships. Actually, America had kept more than 800 warships at Pearl Harbor, which USA was about to deliver to Britain, Russia, France, right? Basically, you might have heard Axis power, Allied powers, these were the two powers fighting. So it was supposed to be given to these three countries. So Japan simply wanted to destroy the entire fleet, entire naval fleet, which was supposed to be delivered to them, so that they can handicap those three countries, Britain, Russia, and France. But when this happened, when the Japanese strike Pearl Harbor, more than 2,000 Americans also died. In fact, 1,500 Americans were there in the USS Arizona ship itself, and all of them died. 1,500. So more than 2,000 Americans died, and you'll be surprised to know, guys, before 9/11, before 9/11 terrorist attack, Pearl Harbor has always been the biggest attack on American soil. In terms of casualties, it is still the biggest attack, right? So this is what we have under in the Pearl Harbor attack. So America took this as a call for a war conflict, and that's when America formally entered into the Second World War. Before this, America was not a part of Second World War. It was simply a supplier of weapons. But then after the 1941 Pearl Harbor strike, America officially became the part of the Second World War, and their interest was technically or typically to fight against the Japanese. And guys, when the Americans wanted to take revenge, they were so furious. I remember Mr. Franklin Roosevelt. He was the president of USA that time. You might have seen his photographs. He was suffering with polio, so he couldn't walk. He was always on a wheelchair, but he was the president at that time. And of course, due to this Pearl Harbor attack also, in 1942, he lost the election, right? And you know that, I think, what was the next president? I think Truman. No, not Truman. उसके बाद कौन president था? चलो, you can check. I think Truman. You can check who was the president, right? I'm unable to recall right now. So so this was basically the point. So in 1941, when Franklin Roosevelt was there, he officially announced that America is now part of the Second World War, but the entire American interest was only to take revenge from the Japanese. And guys, of course, the president would have asked for suggestions from military that what is the right way of taking the revenge from the Japanese. So many suggestions he got. One suggestion was that we can't go for a conventional strike against the Japanese. We can't build a conventional weapons. Conventional weapon means that if we also go and take 50 bombers to the Japanese, of course, America did not have the bomber aircrafts and those what do you call aircraft carriers also at that time. But they realized that if we go for the same conventional way of attacking Japan, then Japan is already in between a war. Their soldiers are already better trained and they have better surveillance than us. So that kind of strike can never cause the same kind of damage. So Franklin Roosevelt got a suggestion that why don't we build a bomb which is so strong that will drop just one weapon, and it will be an answer to the Japanese against thousands of bombs that they can drop on America. And that's when the idea of a nuclear bomb was for the first time presented. And that is when, you might have heard Dr. Robert Oppenheimer. He was called in, he was made the project head for development of the first nuclear bomb. And guys, Dr. Robert Oppenheimer, he was, such a brilliant scientist, and somehow during that time, the position of America was neutral for some time. So many great scientists of that time, like Albert Einstein, Niels Bohr, right, Enrico Fermi, many scientists who were actually the greatest minds of that time, they were somehow living in USA under political asylum. Like what happened, Niels Bohr came late in 1942. Niels Bohr, he was a Danish scientist. Denmark fell under the hands of Germans in 1942, and when it fell in the hands of Germans in 1942, Niels Bohr ran away from his laboratory. From his laboratory only he went and ran away. He did not even go to the house. He, from his laboratory itself, he had to run away, and he came to America. He was teaching at Stanford University. Enrico Fermi, another great brain of that time. In fact, it was Enrico Fermi's idea, which is how we trigger a nuclear reaction, right? This high-speed bombardment of neutron. It was Enrico Fermi's idea himself. He was an Italian scientist, and he made some remarks against Mussolini's government, and he had to leave Italy and run to USA. Fortunately, he was also teaching at Stanford University. Albert Einstein, you guys already know, he was never living in Germany. He was teaching at University of Bern in Switzerland. But you know that was the German part of Switzerland, and that was one of the areas where a lot of German army used to do a lot of activities there. So in 1929 itself, he had to run away. He had to run away from Bern, and he went to England for some time. But from England, he was taken to USA, and he was teaching at Princeton University. So these were the greatest minds of that time, and all these people joined Dr. Robert Oppenheimer under a project called Project Manhattan. Of course, Albert Einstein was there only for a very brief moment, but Niels Bohr, Enrico Fermi, they were till the end of the project. So guys, you must have, if you have not seen the movie Oppenheimer, not a problem, but the movie has very beautifully showcased. I have not seen the movie either, but students have told me that the movie has already all these scientists, their names are there, right? So I have not watched the film. I'm not asking even you guys to watch the film. Okay. So it is just that when you qualify, then you can take a break and watch. Okay. So that's how the team was made, and this project was called Project Manhattan. The objective of the Project Manhattan was to demonstrate a successful nuclear test. And guys, like I said, this particular team involved the greatest minds of that time. These scientists, they made a group in 1942, and it took them around 3 years to conduct a successful nuclear test. Just in a 3-year span, they were able to successfully conduct a nuclear test. And I'm very sure all of you must have seen the images of the Project Manhattan. Even in the old NCERT it was there. You must have seen that mushroom shaped cloud, a massive mushroom shaped cloud, which was nothing but the image of the first nuclear test that was ever conducted. It was conducted in the desert of Nevada. Nevada is an American desert. USA have 2 deserts, Nevada, and what do you call, Mojave. These are the 2 deserts of USA. So in the desert of Nevada, they conducted this experiment, and like I said, it was the greatest minds of that time. It took them around 3 years to successfully demonstrate a nuclear test. It was on 16th of July. The scientists of the Manhattan Project conducted this test, and the moment when this test was conducted, right at that moment, the entire Project Manhattan was shut down. Right at that moment, and the test is remembered in history as Trinity explosion. Trinity explosion. The word Trinity was given by Robert Oppenheimer himself, because by that time you must have heard that he was very much inspired by the Bhagavad Gita as well, right? So Trinity explosion, right? And that's when this event occurred, and right on 16th of July, Project Manhattan was closed, and the entire the entire knowledge, the entire data, the entire experiments, everything was brought under the control of the US Army. Now, one thing I would like to tell you, all these scientists, Project Manhattan involved more than 40 scientists, out of which around 17 to 18 scientists were of civilian backgrounds. These were the actual great minds behind them. And around 28 scientists were from military background, right? So the civilian scientists of Manhattan Project, including Albert Einstein, they wrote a letter. They wrote a letter to the president of USA, right? I'm still not able to recall. I think I don't know how I'm not able to recall. And usually I remember these things, right? So they wrote a letter to the president of USA asking not to develop a nuclear bomb, right? Although, unfortunately, Robert Oppenheimer himself was not in favor of this particular letter. He thought that nuclear bombs can actually solve the problem rather than create a new crisis. He thought that nuclear bombs, once a country makes, people would realize that how dangerous it is and there will be no war any further. This was the opinion of Dr. Robert Oppenheimer, but today we know that he was very naive in his thinking that nuclear bomb can actually solve the problem, right? And that's when he started blaming himself that he became death and all those things, right? Was mainly because he was probably the only civilian scientist out of the entire group who thought that nuclear bomb can be a solution. But all the other civilian scientists, so because Robert Oppenheimer was not in favor, so these scientists wrote a letter to the president, and when they wrote the letter, they asked president not to make nuclear bombs but use this technology for civilian applications. But guys, we all know Americans since day one had a different plan. So they knew that they will be building a nuclear weapon. So on 16th of July itself, the entire technology got acquired and it was shifted to the army. And then we guys know what happened on 6th of and 9th of August. Acha, day before yesterday only, we started the course on 6th of August and tomorrow is 9th of August when, we'll have the anniversary of Nagasaki bombing. So Hiroshima, it was dropped on 6th, on 9th it was dropped on Nagasaki. I hope all of you guys know this, and rest everything is history. Now, why am I telling you, why did I take 10 minutes of your time and talk about this history? Just to give you one opinion. See, when Americans got attacked once, they took revenge from the Japanese, but not from the Japanese army. They were fighting the Japanese army, of course, but they dropped these bombs on civilians. And you may be knowing that more than 1 million Japanese died in both the cities. 1 million, more than 1 million died in Hiroshima, more than 1 million died in Nagasaki. And you may be knowing that they were, thinking of dropping a bomb on Kyoto, on Tokyo and such places. But Kyoto, they opted not to, because one of the secretaries of the Project Manhattan had taken his wife for his honeymoon to Kyoto. So he said that Kyoto is much beautiful, so let's drop it on Hiroshima. This was the fate of those million people, how Americans decided in a single war room. Why am I telling you these things? Because America got attacked once, and they got so furious in anger that they were ready to kill more than 2 million Japanese civilians. India, on the other hand, was subjugated for more than 200 years, almost 200 years, 190 years. We were a colony of the Britishers for 190 years. And you guys know how badly the Britishers have exploited the Indian resources. You guys must have heard Shashi Tharoor, how he has been bashing the Britishers in possibly every foreign universities, saying that India was one of the most richest and the developed countries when the Britishers came. And when the Britishers left, we were dropped down to the poorest and the most underdeveloped countries in the world. You all must be knowing that the true definition of poverty comes from India. Do you guys know this? The official economic definition of poverty comes from India, right? Indians, looking at the conditions of Indians, the definition of poverty has been drafted. The meaning of famines, acute food shortage, comes from India. Bengal famine of 1942, which killed more than 30 lakh Indians, just because the Indian resources were used to fuel the American or the British World War II. Now, when all these things were happening, there was a young Indian scientist. His name was Dr. Homi Jahangir Bhabha. This young Indian scientist, just imagine guys, if you would have been in his position and you would have been a nuclear scientist, you would have thought that let me make one nuclear bomb and drop it on the Britishers itself, right? that would be your intent, because they have literally thrown your country in ruins. But there was this young Indian scientist who studied nuclear technology, and in 1945 he published a research paper. And you know what was the objective of that research paper? That how a country like India can become a civil nuclear power. Can you see the difference of ideologies here? Can you see the difference of ideology? How a country of India can become a civil nuclear power, guys. Right? That means on one side we have countries like Americans, where they had, more than 17 civilian scientists working on a project where they all knew that they are going to build a nuclear bomb. And when they came to know that Americans have rejected the request, they still continue to live in America. None of them left. Niels Bohr left, and some of the other scientists also left after the Second World War. But most of them continue to live in America. Like Albert Einstein died in USA only, right? Many of them continue to live. None of them protested against the American government, right? The only person to protest was, Robert Oppenheimer only later on. So one can easily understand that this shows the ideological difference between an Indian scientist and the group of Western scientists, where an Indian scientist thought of making India a civil nuclear power. And guys, Dr. Homi Jahangir Bhabha, in his 1940, actually the letter came out in 1946. The paper in 1946, he said India should have a 3-stage program. So what the 3 stages you have just written is basically India's official nuclear energy program. And guys, this paper was published in 1946. In 1948, Dr. Homi Bhabha was made the head of Atomic Energy Commission. And in 1948, Atomic Energy Commission, it had other scientists also, but fortunately, Dr. Homi Bhabha was the only scientist who had actually made a plan for making India a nuclear power. So Atomic Energy Commission decided and adopted Dr. Homi Bhabha's 3-stage program as India's official nuclear energy program, or I should say civil nuclear energy program. And guys, since then we remember Dr. Homi Bhabha as father of India's nuclear energy program. I hope all of you guys are able to understand. So these are the 3 stages of India's nuclear energy program. And guys, when you look at these 3 stages, the stage 1, Dr. Homi Bhabha says that the fuel that we should use for powering the stage 1, it should be natural uranium. Guys, he did not say uranium. Remember, it says natural uranium, right? In stage 2, the fuel that he suggests is plutonium. Remember guys, uranium is 92, plutonium is 94. And in 3rd stage, he suggests thorium, where thorium is 90. Guys, tell me, out of uranium, plutonium and thorium, which one is artificially occurring? Tell me guys, out of the 3, I have told you the heaviest naturally occurring element is uranium. So out of U, P and T, you can just add on U, P, T, which one do you think is artificially occurring, guys? Jaldi batao, quickly. No, uranium is naturally occurring. Uranium is the heaviest naturally occurring. Sagar, uranium is the heaviest naturally occurring element, right? It is plutonium. Sagar, do you get it? Uranium is the heaviest naturally occurring element, right? So it is plutonium. Sagar, I hope you are able to get it. Plutonium is an artificially occurring radioactive nuclear isotope, right? It is plutonium, not uranium. Uranium is naturally occurring. Thorium is also naturally occurring. Plutonium is artificially synthesized. Sagar, are you able to get it? So these are the 3 types of nuclear fuels that Dr. Homi Bhabha suggests. Got it? Now look at this. Guys, my question to you. I know many of you may not have studied geography yet. Many of you may not have studied geography. But tell me guys, when you look at uranium, do you have any idea that India do we have good reserve of uranium? Any idea about it? Do we have uranium in India? What do you guys think? Yes, no, anything? What about your opinion, guys? Do we have uranium in India? Bharat, you are saying yes. Okay, uranium we have, but we do not have it in much quantity. Actually, guys, what happens? You know the meaning of the word ore. You understand ore? Ore basically means a mineral composition from where you can extract a certain mineral profitably. You can richly extract a mineral. Like for example, bauxite is the ore from where you can richly extract aluminium. Now there may be a possibility that if I just start if I just extracting or start analyzing the rocks right under my house also, there may be some aluminium found in those rocks as well. But is that aluminium quantity enough to richly extract aluminium? It may not be the case. So ore is basically that particular composition of all the minerals from where you can richly extract a certain mineral. That's called ore. So bauxite is the ore for aluminium. Hematite is the ore for iron. Right? All of you must have heard. Lignite, anthracite, bituminous is the ore for coal. So all these different ores are there from where you can extract minerals or fuels profitably. Now guys, the ore for uranium, the ore that is used for uranium, it's called pitch blende. Pitch blende is the ore from where uranium can be extracted. Pitch blende. Pitch blende is the name of the German scientist who discovered uranium. Right? Pitch blende is the name of the ore. And guys, pitch blende, this ore, pitch blende, it contains uranium, radium and polonium. These are the three radioactive substances that are found in the pitch blende only. In pitch blende, uranium, radium and polonium. Uranium, radium and polonium. Radium I'll write down, and polonium. Right? So pitch blende himself discovered uranium. Radium and polonium, they both were discovered by Madame Curie or Marie Curie. Marie Curie discovered these two. And radium, she named it radium because it had radiation, X-ray, those radioactive radiations. Actually, before her, nobody knew about the nature of the radioactive radiations. So she studied a lot about radiations. And polonium, she named it after her own mother country, right? Her own motherland, that is Poland. She died, she married a French, but she died. She was born Polish, but she died as a French citizen after marrying a French scientist, right? So, in fact, there is one letter which I read. Actually, there are a lot of books of Albert Einstein. So there is a book which is nothing but letters of Einstein, right? It is a combination of more than 200 letters which Einstein wrote to his own mother, right? Later on, those letters were published. And see, when you admire somebody a lot, you tend to read even his non-scientific work, right? So I got an opportunity of reading those letters. I found the book on Amazon, ebook, and I was reading it. And in one of the letters, Einstein has written about his meeting with Madame Curie. So Marie Curie was already an accomplished scientist during that time. And Albert Einstein, when he was young, he went to meet Marie Curie, and she was going on some hiking trip. She planned some hiking trip to basically observe something at the top of a hill. So Albert Einstein accompanied him along in that hiking trip. And Albert Einstein gave a very poor feedback. He says that this lady, she's madly in love with this French scientist, and she keeps complaining about her body pain. Every step she was complaining that my body is paining. And Albert Einstein did not give any positive review. But later on, guys, it was found out that because she has spent so much of time with radioactive substances, that her body has developed so much of cancer in the bones, in various organs, that she had all that pain because of the radiation exposure she has gone through. And you may be knowing that Madame Curie's coffin was actually bolted with thick steel rods, or thick steel and lead sheet, because the body had so much of radiation. Her clothes had so much of radiation because there was so much radioactive dust that used to remain sticking on her clothes. There was so much of radioactive dust in her notebook, in her diary, that everything has been preserved in a way that you cannot release them in nature. That's how radioactive it was, right? So she was actually suffering with the bone cancer that she was facing, right? Later on, Albert Einstein also realized that it was such a pain. And guys, it was because of her contribution, it was because of her sacrifice, I would say, we have learned so much about the radiation, that they can cause cancer, they can cause ionization, mutations, all these things. I hope all of you guys are able to get it, right? So this is the contribution that Marie Curie has made. In fact, there is a unit of radiation which is named after Marie Curie called Curie. Curie is the unit of radiation, right? But I will use the unit which is more standardized called sievert, right? But I'll use that unit a little later. Okay, so there are 3 units for radiation. In fact, 4 units of radiation. Acha, let me tell you one thing first. You will find out that for every single thing there are multiple units. Like when I talk about distance, when I talk about length, there is one unit called meters, then there is another unit called inch, then there is another unit called feet, right? All of them are measuring distance only. Why is it so? That sometimes somebody measures things in feet and inches, somebody measures things in the sense of meters, somebody measures it on centimeters and such. Guys, let me tell you, there is literally, even I also used to get very terrified that why there are so many units for one single thing. So you must have heard of something called SI unit, Standard International Units, right? So what happens? Why do we have so many units of measurement? One of the reason for that is actually, guys, all countries, because we know that initially Europeans did not have intellectual property rights. Europeans did not have any standards. So French used to think we are superior, so they used to have their own units for measurement. Americans used to think they were superior at one time, so they thought their unit should be used. So as Britishers thought we are superior, we will use our own units, and there was a lot of tussle between these countries. They never wanted to use either of the units, right? So guys, what happened? The Britishers, the British king, there was once a British king whose child, when he was born, the size of his thumb became a standard unit for the Britishers. Yes, it's true. The size of the thumb of a British king, British prince, newly born prince, was considered as a unit, and that became inches. So Britishers started introducing inches. It was inspired by the size of the thumb of the newly born prince. Similarly, different people have different opinions. It was the French, for the first time during Napoleon's time, they thought that why don't we standardize these things? Because it is lot of problems occurs when you go from France to Britain and the units changes completely. So it was the French who regularized these units, and they started giving formulas to compare these units with each other. And that's when the French introduced centimeter, which was that time the smallest unit of measurement, and slowly centimeters, 100 centimeters made 1 meter, 1000 meters will make 1 kilometer. All these standardizations started occurring during the time of Napoleon, right? That's why many people say that Napoleon was also a scientific genius, because he kept a lot of scientists in his, lot of scientists and mathematicians in his estates. So all these things started occurring, but before that there were a lot of confusion because of units. In fact, guys, you'll be surprised to know this confusion went on even till the 20th century. There was a mission that Americans and the Europeans jointly developed, a space mission. But the problem was Americans designed products on their own measurement scale, and Europeans designed products on their own measurement scales. And when the entire assembly was made, the project failed. The reason of failure was everyone designed the products as per their own measurement scales. Nobody used a standard unit for measurement, and that became a challenge. So you can understand this can be such a big problem. So especially when it comes to radioactivity also, to measure radioactivity, there are 4 units. There is rad, there is Roentgen. Roentgen is the unit that was named after the person who discovered X-rays. There is Curie, and there is sievert. So many units are there. Of course, today we have the relationship between all 4 of them. There are 4 units. So I will use the unit of sievert, but it doesn't matter which unit you use. I hope you understand all of them were basically used because of all these stupid ideas between the countries. Sievert is SIVERT. Don't worry, we will come to it. It will automatically come in our discussion. I've just shared it, that why am I using sievert? Doesn't make a difference. You can use rad, you can use Curie, you can use Roentgen, right? But it will not make much difference. You can use any one of the units. UPSC will never emphasize on units as such, right? I hope they will mostly emphasize on concepts. So it doesn't change the concept. And mind my words, if you do not remember the units, it doesn't mean that you don't know science. You can understand the concepts. You don't have to remember all the units, okay? Because these scientists came from different countries, and their countries acknowledged their name and gave a standard unit after their name. I hope you understand it was nothing but some superiority or complex that these countries had that time. I hope all of you get it, right? So the ore pitch blend from where uranium, radium, polonium is produced. Unfortunately, pitch blende is not found in India. We do not have rich pitch blende deposits. So pitch blende as an ore is not found in India. So guys, uranium is the stage 1 of India's nuclear energy program, but unfortunately India does not have rich uranium deposits. I am saying rich uranium deposit. We have uranium in Jharkhand. In the Singhbhum region of Jharkhand, we have uranium. Whatever uranium we mine today, we mine it from there, but we do not have rich distribution of uranium. Some uranium deposits may be there, but not rich. So pitch blende is not there. When you talk about plutonium, plutonium is artificially synthesized. So nobody has plutonium, right? And when you talk about thorium, what about thorium, guys? Thorium is a nuclear fuel that is abundantly found in India. In fact, we may be having the largest thorium reserve in the world, and it is found at the Malabar coast, right? Kerala coast, Malabar coast and Coromandel coast. Coromandel coast is the coast of Tamil Nadu. Malabar, Coromandel coast, and also around the coast of Andhra Pradesh, we have got thorium deposits, right? The ore from where thorium is extracted, we call it monazite. Monazite is the name of the sand from where thorium can be extracted, monazite, right? So we have monazite, M-O-N-A, monazite. So monazite ore India has, but India does not have pitch blende. So guys, tell me something. Use your common sense and tell me, if I ask you, what type of capital is the best capital? Tell me, guys, what type of capital is the best capital? Domestic capital or foreign capital? Let me explain. Let's suppose you want to start a new business, and to start a new business, you need money. Let's suppose you have money in your own house and you invest that money and start your business. The advantage of this capital is that all the profit will go to you. There will be no stakeholder, but all the risk will be yours, right? But all the profit, all the development, all everything that you do will be your own money, and this money comes without any debt. This money does not come with any debt. You don't have to repay this money to anyone. This is your own money. But if you bring money from outside, the person who is giving you money, he is not interested in your business. He is interested in his return. So him, you will have to pay the return from day one itself. He will be expecting returns from day one. So tell me, which capital is better capital? The one that you put from your own pockets, it comes without any risk, it comes without any debt, and all the profit is distributed or is given to you. Or the money that you get from outside, because it will come as liability. You have to pay the liability. Even if the company is not doing well, you still have to pay the liability to them, right? Will put an even higher burden on the business. Of course, it is domestic capital. Domestic capital is the best capital. So guys, if domestic capital is the best capital, then don't you think India should have started with thorium based energy? Don't you think India should have started with thorium based program itself? Because this is one fuel which is domestically available in India. Why Dr. Homi Bhabha thought that we should start with uranium? India does not have uranium. India will have to be dependent on other countries to import uranium, and plutonium nobody has, right? So why Dr. Homi Bhabha emphasized on starting with uranium? Why not with thorium? Because thorium is domestically available in India. It is richly available in India. Are you guys having this question? Are you able to understand the question here? Why Dr. Homi Bhabha thought of starting the nuclear energy program with uranium and not thorium, when he also knew in 1942 itself it was discovered that the coast of Travancore, that time Travancore was the name of the kingdom, the coast of Travancore has a lot of thorium which can be a future nuclear fuel. It was known in 1942 itself. So why didn't Dr. Homi Bhabha started with thorium based energy if domestic capital is the best capital? So guys, let me tell you why. Yes, exactly, Sagar. Very good. You have understood the point. So why Dr. Homi Bhabha did not start with thorium and he rather suggested the government of India to start with uranium? Why did he suggest something like that? So guys, I have a question to you. My question is, tell me, what kind of technology is nuclear technology? Is it a labor intensive technology or a capital intensive technology? Does it require good number of labor or does it require good amount of capital? Tell me guys, what type of technology it is? Capital intensive. Very good. See, you can use just alphabets, guys. Just write down first alphabets, it's done. It is a highly capital intensive technology. You require a lot of money to make nuclear energy work, right? You require a lot of money to make nuclear energy work, right? Guys, tell me, in 1947, all of you know, did India have any capital for any kind of research? India did not even have capital to take care of its own people. Do you think government of India could have put money for something like nuclear energy, which was still aspirational at that time? India did not have money for nuclear energy. So guys, capital India did not have, right? And guys, tell me, what kind of human resource is required? Does nuclear energy require low skill human resource or highly skilled people? Tell me guys, what type of skill set is required? Of course, high skilled, right? Highly skilled people are required. Guys, in India, we did not even have a single institution that was teaching physics to this extent. You know, you'll be surprised to know many people say that Britishers got or brought us these high engineering colleges. Of course, the Roorkee Engineering College was made by the Britishers, and it was eventually changed to IIT Roorkee. Right? There were also some more colleges, one in Thane, that were made. But you guys know that the colleges were only offering degrees on mechanical engineering, civil engineering, and electrical engineering. And these degrees were required, or mostly polytechnic, like the Delhi Polytechnic was also made. Eventually that became DCE. So all these institutions were there, but they were all simply meant to serve the British interest, because Britishers brought in railway. They wanted engineers to work in railway. Britishers made those buildings. They wanted engineers to work in those buildings. So they simply wanted to exploit the youth of the country in handling the British interest. Britishers never brought in advanced nuclear physics. Britishers never brought in advanced physics, advanced sciences. All those disciplines were introduced in the foreign universities. So Dr. Homi Bhabha himself studied from UK. He did not study in Kendriya Vidyalaya of India. I hope you understand, right? He studied from UK, right? So this is something which was brought. Even KV itself as a concept was brought in after the independence. So you can understand that India did not have any institution of reputation which could actually offer advanced physics knowledge or advanced scientific knowledge to the people. We only had polytechnics and some engineering colleges. That's it. Like you must have heard, Sir Ganga Ram, he was an engineer from Roorkee Engineering College. He is often considered as the founder of the city, or the chief architect of Lahore, right? There's a very famous hospital in Delhi after him also, right? His family migrated back to Delhi after the partition, but he was the chief architect of Lahore, and he died in Lahore only, and he is remembered. There is a Gangaram hospital in Lahore also, right? So one can easily understand that these institutions were there, but none of the institutions were teaching nuclear physics. You guys would be surprised to know that nuclear physics in India was first being taught at IIT Kanpur. IIT Kanpur was the only institution to start teaching nuclear physics in the country. Before that, in India, we did not have even a single institution. So what I'm saying is that India did not have capital, and India did not even have high skilled resources. High skilled people also were not there, right? So guys, when India did not have the money, did not have the right talent, what is the thing that we can do? We have to rely on foreign countries only to import technology. Actually guys, what happens, Dr. Homi Bhabha in his research paper also, he mentions that India's objective should be to reach the third stage. Dr. Homi Bhabha, his objective was stated since beginning that India should aspire to reach the third stage as soon as possible. We should try to reach the third stage only. That should be our objective, that we should reach the stage 3, because this will be a truly self-reliant stage. But guys, to make the third stage work, India required two set of technologies. There were two technologies that were needed to make the third stage work. What are those two technologies? India needed a moderator based reactor. First thing is India needed a moderator based reactor, number one. Don't worry guys, I'll explain all these things. And second is India needed breeding technique. India needed breeding technique. Now these two technologies we required, only then we could have made our thorium based reactor. Now India did not have the money, did not even have the skilled people, so the only option that we are left with is to borrow technology from outside, is to bring this technology from outside. And guys, look at this. When you look at stage one, do you see in stage one there is a term written moderator here? Actually guys, stage 1 is nothing but a moderator based reactor. Stage 1 is nothing but a moderator based reactor. So stage 1, when he planned that India should get stage 1 reactors from other countries, he was actually building or bringing half of the technology that we need for thorium based reactors, moderator based reactor. Are you guys able to understand? Right? And second is, if you look at the second stage, what does it say? The reactor is, what is the name of the reactor? You have written the full form, FBR, fast breeder reactor. The name clearly says fast breeder reactor. The second stage is the one that is bringing the breeding technology. The breeding technology is in second stage. So breeding technology is stage 2. Are you guys able to understand why Dr. Homi Bhabha came up with these 3 stages? So stage 1 and 2 are being brought in India to support stage 3. Right? And once we reach stage 3, this is our final objective of making India a completely self-reliant country in nuclear energy production. Tell me yes in the chat if you guys have understood why the 3 stages. If you have understood the meaning of the 3 stages, please write down yes in the chat quickly. Right? Quickly write down yes in the chat why the 3 stages. So this was the genius of Dr. Homi Bhabha. So this was the genius of Dr. Homi Bhabha, where he realized that how important it is for us to become self-reliant, and what could be the easiest way to becoming self-reliant, right? Acquire the technology from outside, indigenize it, convert it into the Indian standards, and then build it for India, right? So guys, the plan looks very good, right? All of you would agree the plan looks really good. But guys, the question is, did the plan work? Was this plan a successful plan? So guys, when it comes to stage 1, I would say yes. India received the technology of stage 1, and now we have been able to indigenize. We have made indigenous stage 1 reactors already. Indigenous stage 1 reactors have already been made. India has been able to successfully indigenize. In fact, we have experience of more than 50 years now in stage 1 technology. We are even able to make standards of nuclear reactors up to global standards, right? In stage 1, it has perfectly worked. But guys, when it comes to stage 2, nobody came. Nobody came to give us the stage 2 technology. No country gave us the stage 2 technology. None of them agreed to give this technology to us. Nobody came. And guys, in fact, you may be knowing that Dr. Homi Bhabha died in highly mysterious circumstances. You guys know that he was coming from Paris to India. The flight came from Paris to Sydney, and then from Sydney to Mumbai, right? It was traveling from Sydney to Mumbai, and you guys know that the flight, crashed between Sydney to Mumbai, right? And Dr. Homi Bhabha died in that plane crash. Many people say that Dr. Homi Bhabha, now I'm just sharing a conspiracy theory. Don't write anything in the exam. It is just a conspiracy theory that Dr. Homi Bhabha was trying to crack a deal with the French government, where the French people were agreeing to transfer fast breeder reactor technology to India. He was trying to arrange the fast breeder reactor technology, but unfortunately, because of his death, the entire backdoor channel that he created was shut down, right? So he was using his own connections, he was using his own prestige among the scientist community to help get the fast breeder reactor technology. And because of his untimely death, it is said that India's nuclear energy program got delayed by almost 20 years because of his untimely death. He was such a brilliant scientist, right? And guys, later on in 1985, Prime Minister Rajiv Gandhi took over You know, after the death of Miss Indira Gandhi, Rajiv Gandhi became the Prime Minister, right? So Prime Minister Rajiv Gandhi, he came into power, and in 1985 he restarted India's fast breeder reactor program, right? So it was shut down after his death, but it was not shut down by nothing, no development happened in that. And Prime Minister Rajiv Gandhi restarted the fast breeder reactor program, and in 1985 India also developed a prototype. You understand the meaning of the word prototype? Prototype means a working model, not the final product, but a model, and you will make improvements on the prototype until you make a final product. Okay, so the basic design of the Indian fast breeder reactor was created in 1985, and guys, since then we are working on making our first FBR. Guys, in during the time of Prime Minister Rajiv Gandhi, it was decided that by the year 2000, in the next 15 years, India will be making its fast breeder reactor by the year 2000. In the year 2000, Prime Minister Atal Bihari Vajpayee came into power. He says India will take another 12 years to complete its fast breeder reactor. Then in 2004, Prime Minister Manmohan Singh came. In 2012, I was also preparing for civil services. So I listened to the speech of Prime Minister Manmohan Singh during the Indian Science Congress. You guys know that the Indian Science Congress is considered to be the most prestigious scientific event happening in Asia. But sadly, you guys know that it was stopped, right? Of late, recently it was stopped, right? Because of funding issues, right? So it was a legacy that we created, you know, of the scientist communities in India to have scientific discussions in India, but it was stopped. Although this year we had the Indian Science Congress, but they did not have the funding from the government. Okay, it is organized by an NGO, guys. Remember that. Okay, so Indian Science Congress, while addressing the Indian Science Congress in 2012, Prime Minister Manmohan Singh said that India will be making its fast breeder reactor very shortly. So I thought that maybe in couple of years it will be ready. In 2013, Prime Minister Manmohan Singh again came, and he said India is very close in completing its fast breeder reactor. So I thought that hardly few nuts and bolts are left, and but tight karna reh gaya and it will be ready, right? In 2014, Prime Minister Manmohan Singh again came and made the same statement that India is very close in completing its fast breeder reactor. Prime Minister Narendra Modi then came, and he has been the Prime Minister for 11 years already. He has never mentioned the status of the fast breeder reactor. But guys, thankfully, in August 2020, a news came out from the director of Indira Gandhi Center for Atomic Research that India is likely to start its fast breeder reactor by December 2022, in the next 2 years. Now this is the month August 2025 going on. Do you know the status of fast breeder reactor? Last year the news came that Indira Gandhi Center for Atomic Research, it is the institution under the Department of Nuclear Energy, Department of Atomic Energy, in Kalpakkam, Tamil Nadu, who started core loading. Core loading means that they have started loading the fuel in the second stage reactor, and still the Indira Gandhi Center for Atomic Research director says that by September 2026, Indian FBR would be ready. September 2026, Indian fast breeder reactor would be ready, right? 2026, a dream that was adopted in 1948. It is likely to be completed by 2026. And guys, mind my words, the day this is achieved, the day India's fast breeder reactor starts working, UPSC is 100% going to ask a question, because guys, we have been waiting for more than 80 years for this technology, for more than 80 years of this technology, right? So fast breeder reactor status right now, and we are, guys, even this is also being developed indigenously now, because no foreign country has come. We are also working on the fast breeder reactor indigenously only. And guys, I have no complaints if it has taken such a long time. The reason is, you have to understand that you are dealing with nuclear energy here. One disaster can turn an entire city, can turn an entire town into a ghost town. So we can't take risk. We want the technology to be ready, but ready in an extent, to an extent that it can be actually used reliably, right? I hope all of you understand. Got it, guys? So this is the status of the fast breeder reactor. So we are still yet to start our second stage. We are still only in the first stage. And now, guys, my question is, see, nuclear energy comes at a very high cost. There is a lot of money involved in nuclear energy. And already 80 years have passed, right? Already 80 years have passed, and we are still not in a position to start the second stage reactor. So guys, my question to you is it really worth spending so much of time and waiting for so many years to start the nuclear energy program? Because only after the fast breeder reactor is built, then we'll have both stage 1 and stage 2 technologies, and only then we can start working on the thorium based reactor. And God knows thorium based reactor may take another 10 years, right? Although the prototype of the thorium based reactor is also there, but it will take another 10 years for us to finally make one. So guys, my question is, when you talk about 2025, we are in the quarter of the 21st century is gone. And when you talk about this century, don't you think, guys, there is already so much of innovation in alternative energy technologies. There is already so much of innovation in renewable energy. Solar energy has become the cheapest form of energy today. Can we really justify the investments in the 3-stage program? So my question to you is, do India really needs the 3-stage program now, when already there are so many alternative technologies available? Do India really needs a 3-stage program when already there are so many alternative technologies available? What do you guys think? Should India be thinking about nuclear energy now when there is already so much of alternatives available? What do you guys think? Sagar is saying yes, Bharat is also saying, Vani is also saying yes. So you guys saying yes to the nuclear energy. Still you are saying nuclear energy is more valid. I hope you understand this is not a yes or no question, but I would still give pointers that why nuclear energy is still required. So guys, just think about it. If I compare nuclear energy with that of renewable energy, if I compare nuclear energy with renewable energy, there is no doubt that renewable energy is better. I'm highly in the favor that there is no comparison of renewable energy, because renewable energy comes free of cost. Solar, wind, hydel, all of them are renewable energy, right? They all are renewable energy and they come free of cost. They are naturally there. They are not going to be depleted, right? Except hydel power, other energy sources will not be depleted that easily, right? So there is no doubt renewable energy is best. But guys, there are some problems with renewable energy. The problems are, number one, renewable energy is inconsistent, or I should say intermittency. There is a problem of intermittency in nuclear energy, in renewable energy. It means, guys, right now it is daytime outside, so the solar panels will work without a problem. But guys, at night solar panels will not work. Wind, is it available at the same intensity throughout the year? No. Hydropower also, river, their levels also keep falling and rising. Like right now rivers may be flooded, but in the extreme summers, in the extreme winters, when glaciers are not melting, during that time also the river flow rate decreases. So intermittency and inconsistency. The energy available through renewable energy is never available consistently throughout the year, throughout the day. That is point number one. Okay, that is point number one. It's inconsistency or intermittency, right? So it is obvious that India can primarily use renewable energy. We can have solar power plants set up, but there will definitely be a time when solar energy will not be functioning. And during that time, India would require some backup source. And guys, the most popular backup source today is coal, right? The most popular backup today is coal, but you guys understand that coal itself is not a reliable source anymore because of its bad impact on the environment. Coal is not reliable anymore because it has a very poor impact on the environment. And because it has got a poor impact on the environment, coal cannot be used as a backup. The best backup to renewable energy is nuclear energy. because nuclear energy does not produce any CO2. No CO2 emissions takes place, right? So nuclear energy is not an energy that can work independently, but yes, it could be a very reliable backup energy source for renewable energy. I hope all of you understand. It could be a very reliable backup energy source for renewable energy. And guys, secondly, I would say when it comes to renewable energy, we are still dependent on imports. You guys know that when it comes to renewable energy, India still imports majority of the solar panels comes from Malaysia, Vietnam, China se ban kar diya, but we are still getting it from other countries, right? Wind panels are coming from other countries. India do not have any manufacturing facility that can make large scale or advanced solar panels or wind turbines. When it comes to nuclear energy stage 1 has already been indigenized. It has already been indigenized and has been upgraded to the standards of international safety also. Already been indigenized, right? Acha, remember guys, nuclear energy is a union list subject. You understand the meaning of this word? Nuclear energy comes under union subject. It's a subject under the union list. You guys know that in India there are 3 types of list that differentiates between the work of state government, central government, right? So we have union list, which is basically enshrines all those subjects on which only the central government can make or parliament can make laws. Then we have got the state list, which is exclusively under the state government to make laws. And then we have got the concurrent list. Concurrent list are those where both state and center can make the law, but if the center has made a law, then it is the central law that will prevail, right? It is the parliamentary law that will be imposed, right? So nuclear energy comes under union list. And remember guys, under the government of India, we have got Department of Atomic Energy. This is the nodal agency. This is the nodal agency in India to take care of all nuclear energy affairs. And guys, the chairman of Department of Atomic Energy is the Prime Minister. So Prime Minister is the de facto chairman of Department of Atomic Energy. It comes directly under the Prime Minister's control. And guys, it has been the case since Jawaharlal Nehru, right? Since Prime Minister Nehru was there, it has been the case that Department of Atomic Energy has always directly reported Prime Minister Nehru, right? I hope all of you understand. So all these institutions, BARC, Bhabha Atomic Research Center, it was named after Dr. Homi Bhabha after his death. It was posthumously. It is under the Department of Atomic Energy. Indira Gandhi Center for Atomic Research in Kalpakkam, Tamil Nadu, under the Department of Atomic Energy, does not come under state government. State governments do not have nuclear energy in their subject. And guys, in Gandhinagar, Gujarat, there is Indian Institute of Plasma Research, IIPR. That is also under the central government. I hope all of you understand. All of them come. Then in Delhi, we have Nuclear Science Center. It is again under central government. State government cannot make laws. And guys, when I say it's a union list subject, remember, even the education institutions which can impart knowledge on nuclear energy will also come from central government. So guys, IITs, ISC Bangalore, all or some NITs which are funded by the central government, they will be able to offer courses on nuclear energy. State government institutions will not be able to offer those courses because it is not a state subject. Remember that. So central private universities can also, right? So if there is a private university which is also having a status of a central university, then also they can offer the course. Like Amity Noida offers course on nuclear energy, right? Manipal offers courses on nuclear energy because they have been recognized under the central government by the central UGC central government. I hope all of you understand this. So these are basically the importance of nuclear energy over renewable energy. So renewable energy is heavily intermittent. Its intermittency is a problem, and secondly, it is heavily import dependent. And this is where nuclear energy becomes a very reliable alternative. So guys, nuclear energy is not seen as an independent source of energy, but it can be an effective backup source of energy for renewable energy. Please tell me yes in the chat if you guys have understood the purpose of the 3-stage program and the relevance even in today's time. Please tell me yes in the chat if you guys have understood everything that I've discussed with you so far. It was not technical, guys. It was completely based on the current facts, right? I hope all of you guys have been able to understand. All right, perfect, guys. So this is where we complete our discussion on the introduction of the 3-stage. Don't worry, guys. We'll study the 3-stage completely. This is my guarantee, guys, that once I finish the entire subject of science, you'll be knowing much more. You'll be knowing much more than a basic graduate of science, but not in every subject. Only the areas which I have emphasized on, because we are going to focus on civil service exams. He will know still better in terms of formulas, in terms of practicing and all those things, right? And some nitty gritty they will know better, right? But this is my emphasis, that when I would teach, we should give an idea to every student that is even not taught in BTech or those areas, because our perspective is civil service exams, not BSc or BTech. Now guys, this is what we have. So I have given you the introduction of the 3 stages. Now we'll talk about this later. Let us talk about Acha, we have half an hour right now. Chalo, in that case 40 minutes we have. क्या करें पहले applications करें या चलो let's see this. So please write down types of nuclear reactions. Write down types of nuclear reactions, and then later on we'll see this application of nuclear energy. Okay, types of nuclear reaction. So guys, let me ask you a question here. Let's suppose you guys decide to make a nuclear bomb, right? You decide to make a nuclear bomb. Now guys, tell me, what is going to be your intention behind making a nuclear bomb? Of course, your intention would be that the bomb should be so scary that the enemy should always be scared of us, right? The moment we drop this bomb on the enemy do not have a chance of responding at all, right? It should be so strong that the enemy should be having the idea that yes, India can attack. India is a strong country. Of course, that is the intention of making a bomb. I hope you will not be having an intent of making a bomb so small that nobody is scared, right? ऐसे तो नहीं होगा कि आप bomb बनाएंगे भी and nobody around you thinks that you are a strong country. I hope you understand, right? So whenever a country makes something like nuclear energy, it is obvious that their interest is to ensure that the enemy countries are scared of them. The enemy countries are threatened because you are a nuclear power. Got it? So when you make a nuclear bomb, your intention is that if this nuclear bomb explodes, it will produce uncontrollable amount of energy. If this nuclear bomb explodes, it should produce uncontrollable amount of energy, and your enemy should not be in a position to control it, to contain it. I hope all of you would get it. I hope all of you would have this intention when you make a nuclear bomb, that once the nuclear bomb detonates, it should produce such a massive amount of energy that the enemy is not in a position to control or contain it, right? All of you, I believe, would have the same interest, right? I hope all of you guys are able to understand. This is the intent behind making a nuclear bomb. All of you get it? But guys, if you want to make a nuclear power plant, what should be the interest behind making a nuclear power plant? Do you want a nuclear power plant to explode and let everybody die? No. You want a nuclear power plant so that you produce only enough energy which you can easily control into electricity, which you can easily convert into electricity and control it, contain it and sustain it for a very long period. Don't you think that's the intent behind a nuclear power plant? So when you make a nuclear bomb, the interest is to release uncontrollable amount of energy. And when you make a nuclear power plant, the interest is to control the energy in such a way so that you can produce electricity, you can contain it easily and sustain this energy for a very long period. For 50-60 years, the nuclear power plant should work. I hope you understand. So guys, when you try to classify nuclear reactions, we often classify nuclear reactions on the basis of energy released, right? In a nuclear weapon system, the energy released is often uncontrolled. We want the energy to be released in such a way so that there is no one to control it, no one to contain it. We call it uncontrolled nuclear reactions, right? Uncontrolled nuclear reactions. And this is what we see in a nuclear bomb. And when it comes to a nuclear power plant, what we want is nuclear energy produced in a highly controlled manner. We want only controlled nuclear energy release so that we can control it, contain it and sustain it for a very long period. So are you guys able to understand the two types of nuclear reactions on the basis of energy release? A controlled nuclear reaction means that the energy output is controlled. it is sustained for a longer period. And an uncontrolled nuclear reaction means that the energy output is uncontrollable. You cannot control the energy output at all, right? Nuclear weapon systems. Got it, all of you? I hope all of you understood. This is on the basis of the release of energy. Now guys, how exactly is the nuclear reaction going to work? How exactly do we perform nuclear reactions? So students, there are two ways. There are two ways of producing or conducting a nuclear reaction. There are two ways. One is nuclear fission and the other one is nuclear fusion. These are the two ways how you can produce electricity, or how you can perform nuclear reactions, nuclear fission and nuclear fusion. Now guys, this fission and fusion are just English words. These are just English words, guys. They are not very complicated terms, just English words. Guys, tell me, literally in English, what is the meaning of the word fission? What is the literal meaning of the word fission in English? English में क्या मतलब है इसका? Guys, the meaning of the word fission in English means to, yes, separation, very good. Separate, to break, right? To split, we use the word fission, right? And what is the meaning of the word fusion? You must have heard Indo-Western fusion music, right? Fusion means combining, joining, assimilation, right? So this is fusion. So guys, fusion means joining, fission means separating, right? Separation. All of you are able to agree to this, right? Now guys, if I just put the word nucleus or nuclear in front of fission and fusion, so nuclear fission means separation or breakage of a nucleus into smaller nuclei, and nuclear fusion means joining of two smaller nuclei into one big nucleus. Are you guys able to understand how simple it is? It is just basic English, guys. And mind my words, guys, let me tell you one more thing here. When it comes to most of the words in science, most of the words are taken from English. Most words are taken from English. The reason is because Britishers, their contribution is seen to be quite a lot. So we have taken their language. But guys, when the English language did not have an appropriate word, the Britishers used to take words from Latin, from Greek, right? So that's why we have some Greek and Latin words also. Sometimes if the inventor is French, he will use French words. If the inventor is German, they will use German words. And that is why it is a problem for us, because we are neither French nor British nor Germans. None of these words are in Indian languages. So one can easily understand why people often struggle in science is not because they don't have a scientific mindset, is mainly because we are not able to relate with these words, this language, right? Agar मान लीजिए, if this would have been in Sanskrit, I'm very sure fission means vibhajan or maybe something like that, right? Or fusion would mean sandhi, if I'm not wrong, right? So we would have used these kind of words, right? So it is very obvious that when it comes to, just 1 minute, it is very obvious that when it comes to the language normally is chosen from the people who have been inventors or who have been actively involved in the creation of that particular discipline, right? So for us it becomes a challenge, because first we have to understand English, we have to learn English to an extent, and only then we can understand the meaning of these words, right? You must have noticed even in the subject of environment, I would have broken down all the words for you, right? Like trophos means nutrition in Greek, and that's how the word, autotrophic, methanotrophic, all these words comes, right? So when you understand the meaning of these words, the things becomes really easy to understand. And the same approach goes in for science as well, right? Both the subjects are scientific subjects though. So if I put the word nuclear in front of fission, you can simply create a concept that it means the nucleus is splitting. The nucleus is splitting, the nucleus is breaking into smaller nuclei. As you can see, a bigger nucleus splitting into smaller nuclei, fission. When I put the word nuclear in front of fusion, smaller nuclei are combining and making one large nucleus. You guys can see. So this is simply the meaning of fission and fusion, and these are the two ways how we can generate nuclear energy, how we can release nuclear energy. How simple it is, right? Nuclear fission, nuclear fusion. But guys, let us try to understand the two reactions in a slightly more depth, because this is where UPSC can ask, because this is where we have the main concept of nuclear energy hidden. Okay, so how do we extract nuclear energy? This is where it falls. So guys, you can see the reaction that I have mentioned here. You can see uranium 92 atomic number, 235 mass number, all of you guys can see, right? I hope the yellow color marker is visible to all of you, right? Uranium, this is the heaviest naturally occurring element, remember this, right? And you can, acha, all of you guys must have seen, you know, in earlier in movies and nowadays on YouTube or Discovery Channel, I remember that there was a show on Discovery Channel, Discovery or maybe Nat Geo. In that show, what was the case? That these Britishers, these Americans, they will bring weapons. They will bring different types of rifles, different types of weapons, and they will shoot the rifles. They will shoot these weapons, bullet, to a target. The target that they normally use is a fruit. So they would put an apple, a watermelon, or a pumpkin, anything. And what happens when they would fire, when they would fire that bullet into that particular fruit, the bullet will go at such a high speed that the moment when the bullet pierces into the apple explodes. It explodes literally into small bits and pieces, right? It explodes into small bits and pieces, and that's how they used to see the intensity of the bullet, how strong it is, right? I hope all of you guys can easily visualize. In India also, we have seen those kind of videos in films where, you know, they would put a apple in somebody's head and the hero would simply turn around and shoot, and they will, the moment when the bullet pierces into the apple explodes or the fruit explodes, right? All of you must have seen those. So guys, the same logic is being used here also. We have taken the heaviest nucleus in the universe. This heaviest nucleus have 92 positive, 92 protons, right? 92 protons. That means 92 positively charged particles are there inside the nucleus, and you can understand, to hold all these 92 particles, there will be a very strong nuclear force. Please keep writing why. Yes, if you guys are able to follow, there is going to be a very strong nuclear force to hold all these 92 protons. All of you would agree? A very strong nuclear force is there. So the intent is we have to release the energy of this strong nuclear force that is inside the nucleus of uranium 92. So we have to release this energy, right? We have to release this energy. The concept, now this was the concept that was given by Enrico Fermi. He says that why don't we bombard this particular nucleus with a very high speed neutron? Why neutron? Because neutrons are neutral in charge. Neutrons are neutral. So why don't we bombard this particular nucleus with a very high speed neutron, and the moment when this high speed neutron hits the nucleus is expected to split, it is expected to shatter, and then whatever extra energy, it will shatter and convert into smaller nuclei. Look at this. This is krypton, atomic number 36, very small. Barium, atomic number 56, very small. So what is happening? The bigger nucleus of uranium 235, it is splitting and exploding into smaller nuclei, and whatever extra energy that was there holding the 92 protons, that will be released in the surroundings in the form of nuclear fission energy. Tell me in the chat if you guys are able to understand how the concept of this particular thing will work. See why they have used neutron, because neutron is neutral. It is neutral. If they would have used electron, guys, electron would have never reached, because around 92 protons, there will be 92 electrons and negative charge. So there will be 92 electrons here, right? And negative charge will be very difficult. So electron will be repelling. It will never be able to reach the nucleus. And imagine if you use proton instead of electrons. If you use protons, then proton being positive, it will be repelled away from the nucleus. So proton will also not be able to reach. So Enrico Fermi suggested that why don't we take a neutral particle which will not be affected by protons, electrons, and bombard this neutral particle at a very high speed into the nucleus, and the moment when the nucleus splits, it breaks into smaller nuclei, releasing a lot of energy. And guys, all that energy of the nuclear bomb that I told you yesterday, kilotons, the unit of nuclear bomb intensity, all that energy comes from this, just the splitting of the nucleus. Just the splitting of nucleus. Are you guys able to understand? Just the splitting of nucleus. So this is what basically is the primary concept behind nuclear fission. So guys, now let us see this carefully. So the idea is very simple. We have taken a neutral particle like neutron. We are going to bombard this neutron. We'll increase the speed of this neutron and hit this neutron with a very high speed to the largest naturally occurring nucleus. I hope why? Because it was the largest naturally occurring nucleus that time. They bombarded this. And the moment when the bombardment happened, the nucleus of uranium-235, it got split. You can see it got split into smaller nuclei. Krypton, barium, you can see they are much smaller, 36, 56, uranium is 92. So it gets split into smaller nuclei, and whatever is available is released in the form of nuclear fission energy. But guys, the story doesn't end here. Did you also see that along with this krypton and barium, you can see that there are 3 more neutrons that are produced. Can you notice? 3 more neutrons are there. There are 3 more neutrons that are produced along with krypton and barium. Now what these 3 neutrons will do? Suppose I have nuclear fuel which has not just one nucleus of uranium, but it has millions of nucleus of uranium. Suppose this particular fuel has millions and millions of uranium nucleus. And now what will happen? The first neutron I have bombarded, it will hit the uranium will split and release energy. But as it will produce 3 more neutrons, suppose these 3 neutrons also go and find uranium and hit it. Then don't you think they will break down these 3 uraniums also and produce even more energy? So let's imagine if the energy produced in one uranium is, let's say, 1 unit. If the energy produces 1 unit, I'm not telling the unit of energy here. They mostly use million electron volt use kiya jata. 2.4 million electron volt is the value, but we don't have to get there, right? So suppose if the energy released in splitting of one nucleus is 1 unit, the moment when 3 nuclei are going to be produced and all 3 of them will hit uranium, don't you think energy this time would be 3 units? Right? And guys, from these 3 units, 3 more neutrons will be produced. Are you guys able to visualize? And now there are total 9 neutrons. These 9 neutrons will hit 9 uraniums. And if they all hit 9 uraniums, the energy will be 9 units. And then they will also split. 27 neutrons will be produced. The energy will be 27 units. 27 of them will split. Energy will, the neutrons will be now 81 neutrons. 81 of uranium it will get hit. The energy will be 81 units. And from 81, 243 units. From 243, 729. So what is happening with every nuclear fission, 3 neutrons are produced. And guys, just look at it. How did we trigger this reaction? Guys? We triggered this reaction by simply bombarding 1 neutron. We bombarded 1 neutron into uranium, and when 1 neutron got triggered into uranium, the uranium got split into 3 neutrons, and then from 3 it got split into 9 to 27, 27 to 81, 81 to 243, 243 to 729. It kept on multiplying by a factor of 3. And guys, don't you think the energy kept on increasing by a factor of 3? So guys, we just triggered the reaction. We only triggered the reaction. And what is the trigger condition? High speed neutron. We simply fired the high speed neutron to trigger the reaction, but the reaction on its own became, guys, can I say, the reaction on its own became a self-sustaining chain reaction. Why did I say chain reaction? See, because we have only triggered the reaction automatically produced 3 more neutrons, and those 3 neutrons will automatically hit uranium. They will automatically produce 9 more neutrons, and this reaction will keep on going as a chain reaction. One after the other, the reaction keeps continuing. We did not trigger, we only triggered the first reaction. The rest of the reaction will go on till the time there is uranium left as fuel. Are you guys able to understand? So can I say that this reaction has a tendency of becoming a self-sustaining chain reaction? Tell me yes in the chat quickly. Self-sustaining chain reaction. Tell me guys. This reaction has a tendency of becoming a self-sustaining chain reaction. Right? Self-sustaining chain reaction. Perfect. Now guys, it is a self-sustaining chain reaction. But now look at the energy output. Look at the energy output. In the first reaction, we produced 1 unit of energy. In the second input, we produced 3 units of energy. At the third level, we produced 9 units. Again, as the number of neutrons keeps increasing, the amount of energy also keeps increasing. So guys, don't you think a time will come when the amount of energy would increase to such an extent that the reaction would be so massive in energy that no reactor wall, no reactor surface, or no mechanism would be in a position to control it. Right? If the energy keeps increasing by 3 times at every level, a time will come when this reaction will become so massive, so strong that no reactor surface, no reactor container will be able to contain it, will be able to stop it. That means this reaction that you see here is not only a self-sustaining chain reaction, but can I call this reaction as a self-sustaining uncontrolled chain reaction? Tell me, this reaction in nature is going to be a self-sustaining uncontrolled chain reaction. Tell me guys quickly in the chat. Are you able to understand? Self-sustaining uncontrolled chain reaction. Self-sustaining uncontrolled chain reaction. So we can also call this reaction as self-sustaining uncontrolled chain reaction, because the energy output is going to be uncontrollable after some time, right? And guys, this is the kind of reaction that takes place in a nuclear weapon system. This is what happens in a nuclear weapon system. So guys, when it comes to nuclear fission, nuclear weapon systems have already been developed. They are already there. India has also been able to test it. And India tested this particular nuclear weapon system in 1998. Remember guys, in 1974, we conducted a nuclear test. But in 1998, we declared ourselves as a nuclear weapon state. That's the difference. So 1994, we became a nuclear. 1974, we became nuclear capable country. In 1998, we became a nuclear weapon state. Are you guys able to understand? Self-declared nuclear weapon state, nuclear weapon state. So India has got the nuclear weapon technology that works on nuclear fission. We have the technology now that works on nuclear fission. Got it? Now guys, can this technology be also used for controlling this? Now guys, again my question to you, please pay 100% attention here. So again, what is the trigger condition? Tell me, what is the trigger condition? High speed neutron. High speed neutron. So whenever I'll be showing you the trigger, you have to tell me that it is high speed neutron. So high speed neutron. So we triggered the high speed neutron into uranium, and as the high speed neutron hits the uranium, it breaks the uranium, splits the uranium into 3 more neutrons and energy. Got it? This is how it occurs. 3 more neutrons and energy. It splits. Got it, all of you? Now just think about it. It splits the neutron. It splits the nucleus into 3 or more neutrons. But guys, it is obvious that this reaction, if you do not intervene, will become uncontrollable. And once the reaction becomes uncontrollable, then you can only make nuclear weapons, but not nuclear power plants. So guys, what is the issue with nuclear power plant is that in a nuclear power plant, we want controlled energy. We want the energy to be controlled, right? So how can we control this energy? So guys, the answer is just control the trigger condition. Just control the trigger. If you want to control the energy output, control the trigger condition. What is the trigger condition? High speed neutron. High speed neutron is the trigger condition. If you can control the trigger condition, you can control the energy output. Look at this. See, the moment, look at this guys, pay 100% attention here, okay? Because it's a simple concept and I can finish it in one go now. So when the first neutron hits uranium, uranium splits into krypton and barium, and then it produces 3 more neutrons, right? 3 more neutrons are produced. But guys, let's suppose if by any means, if by any mechanism, just forget it, forget what is the name of the mechanism, I'll talk about it, right? Let's suppose if by some mechanism we are able to stop these 2 neutrons from hitting. Suppose by some kind of mechanism we are able to stop these 2 neutrons from hitting. Kaise bhi, through some mechanism we are able to stop these 2 neutrons from hitting. If by any mechanism we are able to stop these 2 neutrons from hitting and allow only 1 neutron to hit uranium, then don't you think when 1 neutron had hit uranium, it produced 1 unit of energy here, and when it produces 3 neutrons, we stop 2 neutrons from hitting uranium and allow only one of them to hit uranium. Don't you think energy output would still be 1 unit only? And again, when this uranium also split, it produces 3 neutrons, but instead of allowing all 3 of them, we'll stop these 2 neutrons again. We'll stop these 2 neutrons from hitting uranium and allow only 1 neutron to hit uranium. The energy output will still remain 1 unit. And like this, with every subsequent nuclear fission reaction, we just stop 2 of the neutrons from hitting uranium and allow only 1 of them. So what is happening, guys? We are simply trying to control the nuclear reaction in a way so that energy that is produced remains in the controllable limit. Energy that is produced remains in the controlled limit, right? So this type of reaction will be called a self-sustaining controlled chain reaction, right? And guys, the mechanism that we use for stopping the neutrons from hitting uranium is what Hariom was mentioning about control rods, right? But don't worry guys, control rods I'm going to discuss with you when I'll discuss the actual working of a nuclear reaction. Here you just understand and appreciate the concept. So guys, did you see the difference between an uncontrolled nuclear reaction, uncontrolled nuclear chain reaction, and a controlled nuclear chain reaction? An uncontrolled nuclear reaction is made to go uncontrolled. We allow all the neutrons to hit uranium so that the amount of energy keeps increasing. It grows exponentially high and it becomes uncontrollable. But in a nuclear power plant, we have controlled nuclear reaction where we allow the neutron to hit uranium, but whatever new neutrons are produced, we stop some of them from hitting uranium so that we can control the energy output, right? So guys, when it comes to controlled and uncontrolled nuclear energy, I believe all of you understand. And let me tell you, India has already indigenized even controlled nuclear fission reaction. So uncontrolled nuclear fission reaction also we have been able to indigenize, and controlled nuclear fission reaction also we have been able to develop both of them. They both are in place, they both have been developed. Please write down yes in the chat and tell me if you are able to understand, right? So control nuclear chain reaction, simply have to control the trigger condition. You just have to control the trigger condition. You can stop the excessive neutrons, and the moment when you stop the neutrons, you can control the energy output. So when it comes to nuclear fission, I believe all of you guys have understood controlled, uncontrolled nuclear fission. But guys, this was the technology that was developed in 1940s. But you know, in 1950s, scientists were able to find a new method of nuclear energy, and that was called nuclear fusion. And how is that nuclear fusion going to function? We will see it now in the next slide. This is nuclear fusion. This is nuclear fusion. Guys, it is already 9:30, although I started the class at 7:36, right? So, abhi khatam to ho nahi sakta hai nuclear fusion. In no circumstances I can finish nuclear fusion right now. So, क्या करें फिर? कल extend करते हैं फिर. Tomorrow's class I'll extend, right? By 10-15 minutes I'll extend tomorrow's class, and we'll call it off here. So tomorrow when we meet, I'll start with nuclear fusion, and I'll just show you the PPT, what all topics are coming up next, right? The PPT is already with you, by the way, right? So every day I keep posting the new updated PPT with more annotations. So guys, please make sure that you delete the older PPT, because when you get the new PPT, delete the older one, right? And just use the last PPTs that I'm going to upload, because that will have all the annotations from all the classes. Okay, so just delete the older one so that there is no confusion. So guys, after I finish this, I'll talk about International Thermonuclear Experimental Reactor ITER. I'm expecting a question on this because this is likely to be completed by this year December. Then we'll talk about this question. This is one question that I'm going to discuss this in the class itself. Then again we'll go back to the 3 stages of nuclear energy, but this time we'll be understanding the fundamentals of the 3 stages. What is fissile fuel, what is fertile fuel, what is enrichment, all those basic terms, basic technologies. We'll see all those things. And then we'll understand the working of a nuclear reactor. And in this working of a nuclear reactor, you guys can see control rods are mentioned here. So I'll talk about control rods in the working of a nuclear reactor, right? Control rods, we'll discuss it at that moment only. And guys, once I'm done with this working, I'm hoping to finish all this by tomorrow. By tomorrow, I should be able to finish all this. So once I'm done with this working, I will be just, this is something that I'm going to give you in the form of handouts. So I'll be uploading the handout after tomorrow's class once I'm done with that, Indian nuclear reactors. And then we'll talk about some recent achievements. Ye to khair, this Chinese nuclear fusion reactor will complete it along with ITER only. We'll complete that along with ITER, right? We'll then talk about India's nuclear energy program further. What is small modular reactor? What is a floating nuclear reactor? What is the development here? This is all political. Ye polity wala part hai, right? It is all polity related part. So we'll finish the polity part of nuclear energy, right? So I'm hoping that by Sunday we should be able to reach up till this part, right? Although today is Friday, right? Friday or Saturday? Oh, Friday or Thursday? Friday. Okay. So today is the 3rd class. We have finished. So 4th, 5th. Achha, I think nuclear energy will go till the 6th class. 6 classes it will take. Normally I finish nuclear energy in 5 classes, but in your case it will take 6 classes. So anyway, those of you who have not enrolled yet, you guys are still welcome to take the 5 classes. So till Sunday I'll be taking the 5th class, so that we'll upload all the 5 classes one go, and then we'll have a break, right, for 1 week, and then we'll again restart. So 6th class will happen after we complete the 5 classes. Okay. Of course, 6th class will come after 5 classes only, right? So this is, guys, everything for today. We'll be meeting tomorrow and we'll continue this particular part, right? Almost everything that is there in nuclear energy till today, whatever development that has happened in nuclear energy till today, I have covered it in the PPT, and I'll also be covering it in the class itself. So none of you will have any problem. This is my personal guarantee that, see, in ecology, I have told students that except species, other part I can give a guarantee that it will come up from the classes, it will come up from the notes that we provide. Except species, because species, there are a lot number of species. For science, I can even, like, there have been moments when 100% of the paper has come from the class notes. There have been moments like that also, but we can't say that it will always happen, right? Like this time 19 questions were there. Out of 19 questions, 11 to 12 questions were there from the class, right? Still there were 7-8 questions which student would have struggled, right? So we can't say this as a guarantee every time, but science and environment, both these subjects would be very easy for most of you after you go through the classes. All right. So guys, all of you, I hope you are able to understand. We'll meet tomorrow and we'll finish the topic of nuclear technology by tomorrow, right? And leave only the polity part, IR part of nuclear energy. All right. Thank you guys. All the best. Yes, Vani, please.
Sir, we talk about like nuclear test and heating sector. So
Nuclear test?
nuclear test when heating is which was
Yes,
standard
yes,
in
nuclear,
the-
yes,
on this
yes,
sector.
yes. I'll talk about NPT, non-nuclear proliferation treaty. I'll talk about NSG, nuclear supplies group. That's the IR part. And I'll also be talking about, like I have told you about partial nuclear test ban treaty yesterday, 1961. Then I'll talk about the comprehensive, or what is called the CTBT, right? The comprehensive nuclear test ban treaty, which has banned all types of nuclear test. Although I will not be dictating anything about it, I'll just be sharing verbally. You guys are very welcome to write. But NPT, NSG will definitely have a proper discussion in the class because it's a major issue, right? I hope all of you guys are able to get it. So we'll meet tomorrow. Thank you guys. All the best.